All right, so we said we're going to discuss theoretical probability and empirical probability or experimental probability. But let's start with theoretical probability first, and let's see what we can really get from it. It's something really a little bit different from formula method, but you apply the formula method. Theoretical probability is more like a probability calculated without an experiment being performed. So we'll just say no experiment um, for theoretical probability. And most times we deal with the information given. We just solve based on the information given. So it could be an information based on a fair die, it could be an information based on tossing of a coin, and these are just things, theoretical things that um, we solve based on probability. These are things you need to understand, and they are not much things that you would really need to know for you to solve theoretical probability. It's just for you to understand the information, and you should know basic things like the sample space for like a die, um, having one, two, three, four, five, and six, and then for a coin having head and a tail. Yeah, these are just basic things you need to know. Sometimes they can be like extensive. They can ask you like probability involving tossing two coins or even three coins, or maybe probability of tossing a die and a coin. Things like that. So you should understand this basic sample space and understand the information given. Then I think you'll be able to solve any question involving theoretical probability. So we're going to just start with some questions, and then we'll progress to, I think, harder ones and see how much you would understand what we're doing. Um, so let us see the first question. The first question says, two numbers are chosen at random from 1, 3, 6. Find the probability that the sum of the two is not odd. Okay, so I forgot to mention that you can also see things relating to multiples, factors, odd, even. Yeah, so you just understand the information though. All right, so the question shows that there are two numbers that are chosen from 1, 3, and 6. So the numbers here are just 1, 3, and 6. Oops, let me write that well. We have 1, 3, and 6. All right, so from the question, only two numbers are chosen, but we do not know whether it is 1 and 3, 1 and 6, 3 and 6, 3 and, you know, 3 and 1, or 1 and 1, we do not know. We just want to get the probability that we'll take two numbers and the sum of those two numbers is odd. So we're going to put it in a tabular form. So it's going to be something like this: 1, 3, and 6, 1, 3, and 6. So if you pick the possibility that the two numbers you could pick, it could be 1 and 1, could be 1 and 3, could be 1 and 6, and then you have to sum them to see if they are odd or not. It could also be 3 and 1, it could be 3 and 3, it could be 3 and 6, it could be 6 and 1, it could be 6 and 3, 6 and 6, something like that. So if it is 1 and 1, that means the sum will be 2. If it is 1 and 3, the sum will be 4. 1 and 6, the sum will be 7. If it's 3 and 1, it will be 4. If it's 3 and 3, it will be 6. If it's 3 and 6, it will be 9. If it's 6 and 1, it will be 7. If it's 6 and 3, it will be 9. If it's 6 and 6, it will be 12. So it could be any of these possibilities, and their sums are given like so here. Now, the question is, find the probability that the sum of those two numbers that we have chosen is not odd. Okay, I think I was mentioning it's odd before. Okay, it's not odd. I think that's the point. It's not odd. We've learned that when an event is not happening, which is presented by something like this, is equal to 1 minus the probability of it happening, which represented by x. Okay, so this is like saying the probability of it not being odd is equal to 1 minus probability of it being odd. So first things first, let's find the probability that it is odd. So an odd number is a number that is not divisible by 2. And in the sum we see here, um, the odd number here first, we have 7, which is gotten from the sum of 1 and 6. Another odd number is 9, gotten from the sum of 3 and 6. Another odd number, we still have another 7 here. Because of the arrangement, it's 6 and 3, 6 and 1, sorry. And then we have 9 here, 6 and 3. So we have 4 possibilities here, that it could be odd. So 4 possibilities out of the total possible outcome. Um, we have total possible outcome here is the total sample space here. So we have 1, 2, 3. So it is actually out of 9. Yeah, because if you count everything here, it's 9. Everything in this sample space is 9. So the probability that it is odd is 4 over 9. Sure you understand that. Now the probability that it is not odd is equal to 1 minus 4 over 9. Now this is equal to what? 5 over 9. So this is the answer. Okay? So I think you understand the point here. All right. Now let's see the next question. Find the probability that a number selected at random from 41 to 56 is a multiple of 9. Okay, so at this point we have to count the numbers 41 to 56. So we have 41, we have 42, 43, 4, 5, 6, 7, 8, 9, wow, 10, 51, 52, okay, we have 53, we have 54, and then 55, and 56. All right, so now we want to select a number here, but it must be a multiple of 9. That's the point. It must be a multiple of 9. So look through the numbers and see what are the multiples of 9 there. A multiple of 9 is a number that 9 can actually divide without any remainder. So if you check it critically, we have 45 is a multiple of 9. Um, 54 is a multiple of 9. So we have from probability, because we're finding probability that the number selected is a multiple of 9. Probability is of any event is equal to the required outcome, the sum of the required outcome over the total possible outcome. All right, so the required outcome is could be any of these two multiples of 9, 45 and 54, which is we'll just say which is 2 out of the total possible outcomes, which is the total possible numbers that we can take, but we refuse to take them. So because they are not multiples of 9. So the possible outcomes here are 16 actually. If you count from 41 to 56, see that there are actually 16 numbers here. Okay, 41 to 50 here is 51 here is 10, and then the remaining one will give you, yeah, 41 to 50 is yes 10, then 6 plus 10 is 16, okay. So 51 to 56 is 16, okay. So that is, so it's 2 out of 16, and then you reduce it, is 1 out of 8. So that is the probability that you pick any number that is a multiple of 9. Okay, so let's see the next question. Now this is the type of question I was talking about. A coin and a die are tossed up together once. What is the probability of a head and a 6 showing up? So we're going to put this in a tabular form. There's another way to do it, but I think you may not understand why we multiply. So I'm going to leave that till we discuss multiplication rule in probability. So we're going to put this in terms of a table because we have two things tossed here. They decided not to just toss a coin or just a die alone. They want to toss a coin and a die together. So we have the sample space of a die, 1, 2, 3, 4, 5, and 6, and a coin, head and tail. So when you toss these two objects together, there's a possibility that it could land with head and a 1 for the die. It could land with head and a 2, and head and a 3, head and a 4, head and a 5, head and a 6, something like that. And then tail and also, understand what I mean. So head and 1, head and 2, head on 3, head on 4, head on 5, head on 6, and also tail on 1, tail on 2, tail on 3, tail on 4, tail on 5, tail on 6. So these are things that could happen when you throw a coin and a die at the same time. But the question one, they want us to find the probability that it is a head and a 6 showing up. So the probability that once you do it, it's a head and a 6. So, well, since they say once, the probability that it's a head and 6 appears just once here. So it appears one out of all the possibilities, all the things that could have happened when you're trying this event is out of 12 possibilities, because I think this is 6 here. 1, 2, 3, 4, 5, 6, then times 2, 12. Okay. So everything in this sample space here, everything here is 12. So just 1 out of 12. That is the probability of getting a head and a 6. This is it here. Okay, so you can always ask questions if you have, if you do not understand anything we're doing here. All right, now this is one question also that you need to look at. Um, if you understand up to all the things we've been doing, understand how we form tables, understand how we solve based on the question from the information of the question. I want you to try this one out. So you pause the video, try this out, and then we'll come back and we'll solve this. And let's see if you truly understand what we've been doing. So I want to assume that you actually pause the video and try this out. But if not, it shows that maybe you really understand it already. But let's see what happens if we solve this. So the question says if two perfect dice are thrown once, find the probability that they give a total of 6. Okay, so two perfect dice, meaning that this is not a coin and a dice this time. We have two dice, that is dice. So if we put it in table form, we have 1, 2, 3, 4, 5, 6. This is one die, die 1. We have another die, 1, 2, 3, 4, 5, 6. This is die 2. Okay, now when you throw a die or more than one die, that's two dice. Um, Most times, if you're using it in a game, you always count the total that appears. So if it is 5, 4, you count it as 9 and then use it to do your game or stuff. So the possible outcomes that can come out of throwing two dice could be 1 and 1, could be 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 2 and 1, 2, 2, 2 and 3, 2, 5, 2, 6, stuff like that. Could even be 6 and 1, 6 and 2, stuff like that. But we're looking at their total. Um, their total. So if it is 1 and 1, the total will be 2. If it's 1 and 2, the total will be 3, 1 and 3, 4, then you have 5, you have 6, you have 7. 2 and 1, you have 3, you have 4, you have 5, you have 6, you have 7, you have 8. You have for 3, 3 and 1 is 4, 3 and 2 is 5, and then 6, 7, 8, 9. And then 4, you have 5, 6, 7, 8, 9, 10. You have 6, 7, 8, 9, 10, 11. You have 7, 8, 9, 10, 11, 12. All right, so you understand what we're doing basically. So we're just looking at the sum of whatever it lands on. So for 6, we'll see that it could be 6 and 1, 6 and 2. So we have 7, 8, and then 9, 10, stuff like that. But we want to see the probability that they give a total of 6. So all the things you try out, what else actually the possibilities that the ones you tried gave you a total of 6. So if you look at it, the ones that actually can give a total of 6 is 1 and 5. 1 and 5 can give you a total of 6. This is 1. 2 and 4 can give you a total of 6. 3 and 3 can give you a total of 6. 4 and 2 can give you a total of 6. 5 and 1 can give you a total of 6. All right? Now, these are 5 possibilities out of the total possible outcome. The total trials is actually going to be 36. If you count it, this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If you multiply, that's 36. So everything here is actually 36. So this is the probability that you would get a total of 6 if you were to throw two perfect dice once. All right. So I think yeah, that is all for uh problems in theoretical probability. Now, if you want us to solve more questions so that you to increase your understanding, you can tell us. You can just leave it in the comment section below. If you do not still understand, you can um, point out what you do not understand in the comment section below. And if you need private classes on this, you can also do that. We normally have private classes via Zoom. Okay. And if you've not subscribed, please try and do that. Show appreciation for um, our detailed explanation. We really appreciate that if you subscribe. If you can like also, it will be good. So next time, I think we'll be looking at empirical probability, experimental probability, and also see what we can get from that. Thank you very much.